Hi, my name's Dan, and this video is one in the series that I'm doing on digital electronics logic circuits. This short series is about binary decoders. We're coming to the end now. I'm going to demonstrate a 2-bit decoder with enable. So in the previous video, I did a 4-bit decoder with enable. A 2-bit decoder with enable is actually somewhat simpler. Um, and this is all part of a larger ambition, which is to go from the basic logic gates to creating a simple CPU computer core. There's quite a lot of videos to go in that ambition. There's a roadmap in the description below. We're in the first playlist on that, which is about decoders. To understand this stuff, you'll need to understand gates and some simple stuff about digital circuits. I'm using Digital Works software, which is simulation of digital electronics. It's free software, and also in the description below there will be a link to that where you can get it for yourself. So when we did, if you've been following on the series, when we did the 4-bit decoder with enable, what we did was we used the 4-bit decoder that we'd already built. What I'm going to do, the reason why I'm doing this as a separate video, for a 2-bit decoder with enable, which could be really easily done just using the 2-bit decoder we've already made and using the same process. But actually, I'm going to build this one from scratch because you can save some gates. Now, with the 4-bit decoder, partly I wanted to show you this kind of cheaty way of doing it, but with the 4-bit decoder, we couldn't actually save more gates because we're already using 4 input AND gates for our decoder. With a 2-bit decoder, though, we're only using 2 input NAND gates, and so we can add our enable directly into the NAND gates. Let's have a quick refresher of what the 2-bit decoder looks like by dragging the component in, and I'm just going to double-click on that to open up the macro. So we've got 2 inputs, which is the binary input. We've got 4 outputs. And what we want is for each of these outputs to also have an enable built in, and we can do that by adding another input to each of these. So using 3 inputs, and then the 3rd input is going to be the one that we're going to add the enable onto. So we're going to close this and do it from scratch again. But it shouldn't take us too long to do this. We're going to need a couple of lines for our input. So let's set that up. And this is what I normally do, is to set these up as longish lines that we can tap off. And let's have another one, because I'm going to then stick a NOT gates in. So if you don't understand the process of what I'm doing here in producing a binary decoder, then there are other videos in this series, and you should probably go and watch the one on the 2-bit binary decoder, because it makes more sense if you know what's going on there. And all I'm going to do here is select that, do a copy and a paste, so that I've got 2 that are the same, and then I'm going to use 3 bits. 3 inputs and gates. 2 inputs are going to be for the binary number, and the other 2 inputs are going to be for so the other inputs on each one is going to be for the enable. So let's set up the binary numbers first. If you remember, the second line is the one that's high when the input is 0, and I remember that because it's got a little blob on this NOT gate which looks like a 0. So we want 0, 0, 0, 1, 1, 0, 1, 1. That's our binary numbers coming in. So 0, 1, 1, 0. I'm not even going to fast forward this. 1, 0, 1, 1. I've done that right. And then I'm going to add the extra tag for the enable, which is going to come to all 3 of these inputs. And the point of this is that only when the enable line is high will the decoder effectively actually work and give you an output. There we go. And 4 more tags for the actual outputs. 1, 2, 3, 4. I'm going to wire those up. It's a good practice to stick some annotations in so that if we're coming back to this at another point, we understand what's going on. So that output 0, 3. Because we've got 0 at the top, we're going to rotate that way so that the 0 to 3 aligns with the way we're doing it there. And we're going to have inputs. Input 1, 0. And I've just put in out, not input. And then our final input is the enable input. Right, so to turn this into a macro, as you should know by now, into the template editor, we're going to reduce down what we've got here. We still need the enable. We only want 4 of these outputs. So let's get rid of a load of those. Change the annotations. Output 0 to 3. Inputs 1 to 0. And the rest of this is a bit of tidying up, making sure that change the name of the thing. Otherwise we get confused. And in fact, the fact that this is quite a long name is going to define how wide we're going to have this, I think. Do we need it to be particularly short or smaller? Well, it might save some space if we did, but I'm not too bothered. Pull that across. And I've left 5 pins, not 4. Can't count. Just tidying this up. Finally, let's close that and do our connecting up. So you should understand this process now. If you're coming straight into this from outside and haven't seen the previous videos, then this might seem like a bit of a strange thing to be doing, but this is the way that Backer was created. If you don't understand this, then I've got a video all about that, so you can go look at that if you like. And basically, I'm just keeping my mouth moving and saying things to justify the fact that I haven't speeded up this bit, which I could have done. If there was a lot of it to do, I would speed it up, but only one more to do. That's the last pin to be connected. So I'm going to save this as a macro and then do a quick test. Save as, and it's a decoder 2-bit with enable. And so a new circuit and pull that new component in. And we're going to need inputs and outputs. A couple of inputs and another input for the enable. And outputs. Now I haven't. When we did the 4-bit one, which you may well have been watching, then because we based it on the existing decoder, I didn't feel the need to do an exhaustive test. However, this one I have wired up from scratch, so I am going to do a full test of this to make sure all 4 binary numbers work correctly. So just start the simulation running. No output at the moment, even though we've got 0, 0 on the input because we've not got enable. So if we hit enable, that gives us the first one. Let's change the input. And that gives us the second one. Change that to 1, 0. Should give us the third one. And finally, the 4th one. There we go. And that's it. So actually, a 2-bit decoder with enable is simpler than a 4-bit decoder with enable. And the real reason that I've done it isn't just to show you integrating it all together, but actually later on, much later on in this process of creating a CPU, we're going to need a 2-bit decoder with enable. So it fits in with the rest of the stuff in this series to do it now. And that's it from me for now.